Hello students, welcome to today's class. This is Guru. Hope you are all doing well. Today's topic is sound. Very interesting topic, right? In this class, we will understand what is sound, how the sound is produced, how it is transferred, how do we hear sound, how does the sound waveform look like, what is wavelength, frequency, amplitude, time period, in which medium sound travel faster and why, what is the speed of the sound, what is echo, what is noise. We will look at all of these things in this chapter. Let's get started. What is sound? Okay, I'll give you two definitions and then I'll explain them. Okay? One, sound is a form of energy. Okay? And second one, sound is a physical sensation felt by our ears. Now let's look at a song. Yes, you are looking at a song now. Will you be able to recognize which song is this? No, it's impossible because you haven't heard it. It is impossible to identify the song or even some voice or even don't know whether it is some noise, right? We don't even understand what it is until we hear it. That is why we said sound is a physical sensation felt by our ears. Now, sound is a form of energy, right? We all know energy is something which can be converted from one form to another form. Will we be able to convert sound from one form to another form? Let's look at it. I will give you a live example. I am teaching and you are listening, but I'm not in front of you and teaching, right? You're not listening to me directly, but how is my voice reaching to you? Let's look at it. I am producing a sound here, but you are listening at a place which is far, far, far away from me, right? I'll explain it. Here is a microphone, right? The sound which I am generating is inserted in this microphone, correct? And wherever you are, you have a speaker in your laptop or computer or even mobile phone. From the speaker, the sound is reproduced and you are able to listen to it, correct? So here, the energy which I am generating is a sound energy. And this microphone is converting the sound energy to electrical energy and transferring it via a wire. The same electrical energy converts at your end in the speaker to transfer from electrical energy to sound energy. That is why we call sound is a form of energy. Sound is a very important thing to all of us, including animals. Why? Only with the sound you will be able to hear your mom calling you for breakfast, for coffee, for drinking milk, right? Same way, for animals, sound is the one which can help them to escape from their enemies. By listening to the enemy's footsteps, animals escape from wherever they are and get rescued. Just think of another examples where sound is very helpful for you in your daily life, like father calling you whether you have done your homework or not, right? Think similar examples. Sound is a form of energy. Energy is also the ability to do work. You all know, right? But what work does sound do? Before understanding this, we will understand how sound is produced. Okay? Here I am producing sound. Okay, I'll ask you to keep your fingers on your throat. Okay, now make some sound. Hello, hello sir, how are you? Did you feel something? Yes, I felt some kind of vibration in my fingertips. Did you feel the same? Obviously, right? There is a vibration in your fingertips. You felt. Okay, now we look at different musical instruments producing sound. Okay, let's look at guitar. Guitar is the one producing sound by vibrating the strings. You see, the strings are vibrating to produce the sound. Okay, now we look at veena. Veena is a similar example like guitar where you vibrate the string to produce the sound. Okay, here is the drum where you are hitting the drums to produce the sound. Where is the vibration happening here? The membrane. The membrane on the cylindrical structure, you are hitting it and the membrane vibrates to produce the sound. Here is the flute. Where is the thing which vibrates to produce the sound here? There is nothing to vibrate, right? No, there is thing. Okay, there is a air column. If you look at the flute, there is a air column where you blow the air to produce sound. In the flute, if you look at, there are other places where there are holes. The musician will hold the holes one after the other to produce different sounds. The air molecules in the air column colliding with the surface of the flute producing the sound. You got it, right? I will give you another example. Take a balloon, blow the air inside the balloon. Okay? Blow the air so tightly, okay? Suddenly the balloon burst, making a blast sound, right? Why is it happening? When you blow the air into the balloon, the air is getting compressed inside the balloon. When it bursts, the compressed air released suddenly, causing a huge vibration in the surrounding, which makes the sound blast. What you understood from all these examples? Vibration produces sound. Without vibration, there can be no sound. Vibration is the main thing if you are hearing any sound. Understood? There is one thing you need to understand. The sudden compression and expansion of gas produce sound. How? Let's take this example which we did before. Balloon experiment. You blew the balloon. There is a compression of gas inside the balloon. Once the balloon burst, there is an expansion of the gas, that is the compressed gas expanded to produce sound. The compression and expansion of the gas produce sound. Vibration means moving back and forth. Okay, moving back and forth, right? In the compression and expansion, the gas molecules moving back and forth, like compression and rarefaction or expansion, you can remember. Okay, so how do we produce sound? There must be something inside us which is producing sound, right? Yes, right here, which is called voice box or larynx. Larynx is the another name for voice box, okay, which is located at the upper end of your windpipe. Okay, here is the view of your voice box. If you can see, there are two membranes which is called vocal cords, and there is a small gap between those two membranes, right? When we speak, your lungs pushes the air through that gap, vibrating the vocal cords to produce sound. But one person can produce different sounds. Hi, hello, how are you, right? And also each person has different voice. I cannot talk like you and you cannot talk like me, right? And even females has a different kind of voice. Males has a different kind of voice. Children's has different kind of voice. Why is that? The voice box which you have, the length of this voice box vary for men, women and children's. The length of this voice box for men is 20 millimeter. For ladies it is little lesser, and for children's it is more lesser. That is why men sound differently and women sound differently and kids sound differently. Also, the muscles attached to this vocal cords loosens and tightens to produce different voice. That is how I can generate different kind of sound, right? Now we understood how we produce sound. But how do you listen the sound produced by others? For that we will understand how sound travels. Okay? Let's do a small experiment. Take a stone and put inside a stagnant water. What do you see? You see ripples forming in all the directions, right? It looks like water is moving away from the source. Do you think water is actually moving away from the source? That means water should get empty, right, in the middle? No, water is not moving away from the source. It is moving up and down in its position. Sound wave travels similarly, but the vibration of the particles of the medium is in the direction of the sound wave itself. Let's take an example how sound travels. You all would have played with slinky toy, right? Let's take the slinky toy and tie one end of the slinky to the table. Give a push from the other end and observe. The slinky moves back and forth in its length, right? It looks like it is moving away from the source, correct? But it is not moving, it is actually moving back and forth. Now observe the pattern. At some places you see the rings of the slinky are very close, okay, which is called compression. And at other places the rings are far away from each other, right, which is called rarefaction. We observe alternate compression and rarefaction all along the length of the slinky, which is called longitudinal motion. The sound wave travels exactly the same way from one place to another place by creating alternate compression and rarefaction. Okay? I producing sound, that means I'm transmitting energy to the surrounding medium. The medium here is air, right? Let's look at it. I'm transmitting sound, the medium is air. As soon as I transmit, the air particles here gets the energy from the sound wave which I am generating, right? The energy is transmitted to the next particles by the vibration. Okay, the next particles receives the energy and moves forward. Similarly, the next particles receives the energy and moves forward. This creates alternate compression and rarefaction continuously in the air. When this process continues, it produces alternate compression and rarefaction in the air before it reaches to your ears, right? Let's look at what happens in your ears. How do you understand whether it is some voice or music or some noise? Here is the explanation. Inside your ear there is a small membrane called eardrum. When you receive the vibration, the eardrum vibrates just like the drum vibrates when you beat it, right? The vibration makes the eardrum vibrate. which in turn vibrates the tiny bones inside your middle ear part called malleus, incus and stapes. These bones vibrate also, which amplifies, that means it increase the vibration and transfer it to cochlea, the inner part of the ear. This cochlea contains liquid inside it. These vibration makes that liquid to form waves inside it. The hair-like structure below the liquid takes the vibration and makes the movement. Along with the ions produced by the movement of the hair-like structure generates the electrical signal and transfer it to the brain. That is how the brain will understand what kind of sound it is. Whether it is music, noise or some voice, it will be understood by the brain. So now you understood how the ear works, how you will be able to receive the sound from the surrounding, right? Now you all understood what happens when sound travels in gaseous medium, that is air. But what happens when there is no medium at all? What I meant is in vacuum. In vacuum, does the sound travel? Let me give you a small example. Outside our Earth atmosphere, it's all vacuum, right? Also, there are huge stars like sun and different kind of objects in the vacuum, that is in the outer space. They are colliding and making huge destructive noise and all every day. Will you be able to hear that sound? No, because there is no medium in the space so that sound travel to us and we will be able to hear. It is not possible. Let's take an example, okay? Let's take a jar and a mobile phone, okay? Keep your mobile phone inside the jar. Now give a ring to your mobile phone. You will be able to hear the sound, right? You will be able to hear the ringtone. Now close the jar lid and suck the air out, just like this, okay? Suck the air out as much as possible. You will be able to listen to the sound but very faintly, like sound gets reduced. Why is it getting reduced? You are removing the air out of the container. That means you are creating a vacuum. That is why the sound faints. So sound doesn't travel in vacuum. That means where there is no medium. In gaseous state, that is air, we will be able to hear. That we understood, right? Now we look at the other mediums. What are the other mediums? Solid and liquid, right? Whether sound will be able to travel over solid and liquid, let's look at it. So what we understood from the previous gaseous state example, that means when I produce a sound, the air particles moves and it transfer the energy to the next air particles, and the next air particle transfer the energy to the other particles. Like that it continues, right? In solid, the molecules are closely packed, and in liquid it is a little less closely packed, not like in gaseous which are free, right? In gaseous states, the molecule transfer the energy, it takes time, right? But what happens in solid? They are closely packed, right? When there is a vibration in the solid, it has to move instantly. That means the closely packed molecules will receive the energy instantly, right? Let's imagine all of us are in small room. We are all closely packed, just like this, okay? We are closely packed. If there is some external energy like vibration or some push, right? I started moving. Instantly I transferred the energy to the next person, and the next person instantly move. Similar way, the whole hall, the whole room will immediately move. That means everyone in the room immediately move, right? So in solid, the molecules moves instantly one after the other. That means the transfer of the energy is very fast. That means sound travels faster in solid. Let me give an example to understand this. Okay, do one thing, sit on a table and keep your ears on the table. Okay, just like this. Ask your friend to scratch the table on the other end, on the far end. Okay, scratch the table. Okay, how will you be able to hear? It will be like loud noise, right? When you keep the ear on the table, it is a loud noise you are hearing. Why? Because the medium is solid. If you remove the ears and now hear the sound, you don't hear much sound, some sound, right? But when you keep the ear on the table, it is a loud noise. Let's see what happens in liquid. In liquid, the molecules are not so close as in solids. We all know, right? So let's consider in a room you all are there, but with 1 foot distance. Okay, 1 foot distance you all are having. Okay, now some external energy or a push came. Okay, so there is a vibration. Okay, the energy I need to transfer to the other person, right? Here I take some time because I need to move to some extent to transfer the energy to the other person. So it takes a little time to transfer the energy, right? So the molecules in liquid are little far away. In solid you can take, they are tightly packed. In liquid, a little far. So the transfer of energy is happening. So the sound does travel in liquid, and the speed of the sound in liquid is 1500 meter per second at an average. Okay, in gaseous state we already discussed sound does travel like in air, and the speed of the sound in air is 340 meter per second. This is the reason why when there is a thunderstorm, you will be able to see the lightning first and the sound later. What is the SI unit of the sound? It's meter per second. Just now we said, right? What is the speed of the sound in air? 340 meter per second. Meter per second is the SI unit for speed of the sound. Now we look at the sound wave example. Let's go back to compression and rarefaction example. Okay, so here let's observe a single particle movement. Okay, when there is a sound wave, there is a vibration and the particles is moving, right, to and back and forth. Okay, so if you observe a single particle movement, it is from its stagnant position, it is coming forward and going back and again backward and coming back and coming forward, going back and going back and coming forward. So this process is repeating, right? If you draw a line across the time of the travel, right, you see a wave like structure, right? Yes, there is a longitudinal wave. That is how we represent sound wave also. Let's look at this wave. Okay, let's use this wave to explain the characteristics of sound. What are the characteristics of sound? It's wavelength, frequency, amplitude and time period. Let's look at one after the other. What is wavelength? The distance between two successive identical points is called wavelength. In this wave, what are the two identical points? It can be two higher points like crests, or it can be two lowest points, two troughs, right? So it is called wavelength. The distance between two successive crests or the distance between two successive troughs is called wavelength. The wavelength can also be defined as the two successive identical points in the wave. That means anywhere in the wave, two identical points. That means if the wave is like this, anywhere you take the point, and the similar point if you take in the next wave, that is called wavelength. And how do we represent wavelength? Using a symbol called lambda. It is a Greek alphabet which is pronounced as lambda. Okay, different sounds has different wavelength. Okay, now let's look at what is frequency. How loudspeaker works? By vibrating, by moving up and down, right? Like when I produce sound in the air particles take the energy and transfer it to the next molecules that moves back and forth. That is vibrating, right? So how many vibrations happening in 1 second is called the frequency. If you look at this diagram, let's consider this traveled in 1 second. Okay, if you see, there are 3 waves, right? 3 waves in 1 second. That means 3 waves traveled in 1 second. That is 3 is the frequency of this wave, and frequency is represented by hertz. Hertz is the SI unit for frequency, and the frequency of this wave is 3 hertz. But we will not be able to listen to this sound. Do you know why? Let me explain you. 3 hertz is not audible frequency for humans. The human audible frequency is from 20 hertz to 20 kilohertz. If there is any sound which is producing 20 to 20 kilohertz frequency, then only a human can hear the sound. If the sound is below 20 hertz, we call it as subsonic. If the sound wave is above 20 kilohertz, we call it as supersonic. Okay? Let's assume there are 40 such waves traveling in 1 second. What is the frequency of the wave? Correct. It is 40 hertz. Is it audible or not? Yes, it is audible. Why? Because it is above 20 hertz. Okay? Now let's look at what is amplitude. Imagine you are listening to some music. Okay? So sometimes you will be hearing music with loud sound, right? And sometimes you will lower the volume and listen to the music. What exactly you are increasing and decreasing? What is volume? Which is nothing but the amplitude. The amplitude is the loudness of the sound. If you observe the sound waves here, when I talk with a loud voice, the wave height increases. When I talk with a light sound, the wave height decreases, right? So what you understood from this? The height of the wave is nothing but the amplitude. Okay? The height of the wave from its start point is the amplitude of the wave, which is clearly shown here. Okay? The height of the wave from the start point is the amplitude of the wave. Now let's look at what is time period. Time period is nothing but the time taken to travel one cycle, which is inverse of frequency. Let's do a basic math. Okay? In this example, 3 waves take 1 second to travel, correct? Now we will see how many seconds it takes to travel one wave, right? It is nothing but 1 divided by 3 seconds, correct? 1 divided by 3 seconds for one wave. 3 waves 1 second. For one wave, 1 divided by 3 seconds. What it will be? It is 333 milliseconds, correct? Okay, so now you know how to calculate time period, okay? Now let's imagine you are in a hall, a 4-walled hall, okay? There is no chair, table, nothing, and you make a loud noise. What you will hear back? You will hear back your own voice multiple times. What is happening here? Why are you hearing your own voice? Okay, in your previous classes, you have already learnt about light getting reflected, right? If there is a light falling on an obstacle, it will reflect, at least a part of it get reflected, right? Similarly, the sound wave also reflects when it hits a hard obstacle. That is why you will hear back your own voice, which is called echo. So you might have observed in theaters there will be a cushioning effect even for the walls. Why? To avoid this echo effect. So what is noise? Noise is something which we don't want to hear. I am teaching now, but there is a background noise, right? Some shh kind of noise which we don't want to hear, but we cannot avoid some such noises, right? So we call that as noise. Even if someone is talking outside, that is a noise. They are talking, but for us, which is irrelevant, which we don't need, that is called noise. That means sound which we are not interested in, but we are hearing it, it is a noise. I hope you understood all of these topics, right? So we will look at what all we learned today, okay? Now we know what is sound, how sound is produced, and how sound is traveled, and how we produce sound, how we hear the sound, what are the characteristics of sound wave like amplitude, frequency, wavelength, time period. What is echo? What is noise? So students, we all know all of these things, okay? I hope you enjoyed learning sound chapter, okay? Thank you. We will meet again in our next class.